So hello everyone. So welcome to today's webinar for the Focal project. So my name is Ryan Ahola. I'm a geospatial expert with Natural Resources Canada. I'm based in Ottawa, Canada, and I'm one of the co-chairs of the Open Geospatial Consortium's, or OGC's, Climate Resilience Domain Working Group. So we've been working with the Focal project coordinators to help facilitate some of these webinars, which have been helping to engage the community with the different activities that Focal is working on. And so we're just trying to help bring the community together in a sense, and also learn from what the community is doing to help improve the different standards activities that OGC is working on to improve geospatial interoperability. So today what we're looking at is a specific webinar that's looking at how a concept called STEEP is being used within the Focal project. So my understanding is that STEEP is a cloud-based workflow management system that orchestrates different types of microservices to process big data in a manner that's cost efficient, both from a cost and a resource perspective. So the presentation today is going to cover how this type of approach can optimize the training of different types of AI applications in a few different ways. So today the presentation is going to be delivered by Kevin Kocon. Sorry, I'm probably mispronouncing your last name. Apologies for that. But he's the research associate at the Fraunhofer Institute for Computer Graphics Research. So with that, I'll pass the floor to Kevin to start the presentation. Thanks.
Okay, yes. Yeah. So I think, can you see my slides and can you hear me? So if not, okay.
Yes, yes to both.
Okay.
Yeah.
So yeah, thank you very much for the nice introduction and for handing over in the nice webinar series. Also welcome from my side. My name is Kevin Kocon and I will present you today the topic supporting AI training with STEEP, workflow integrated AI training and provenance. Before I jump into the details, into the slides explaining what STEEP is and why workflow integrated AI training, I would like to say some words about the background. So you already explained, this is part of Focal. What is Focal? Focal means efficient exploration of climate data locally. And the main goal of this project is to make the climate data and also the climate models better usable and accessible also in local regions. So besides important topics like climate modeling, like climate data, like metadata catalogs, all these topics are already presented in past webinars by my colleagues. Another important point is development of a platform to support the entire AI development pipeline. And this is the topic and the main goal I will present you today in the next minutes. So why this is important? The artificial intelligence AI technology has become increasingly popular and powerful in the recent years. And it sounds very easy. And if you use AI, this is also very easy to use. But behind this magic, there is a very hard process to develop this magic, I will call it. So developing AI is just not the model training itself, but it's a whole pipeline. So you have to start the data preparation, you have to do some feature engineering, then you have the model generation where also the training is a part of it, and then you have the model evaluation and deployment. And without simplifying these steps through automatization, it is very hard to do this starting by scratch, because for every part you need experts. So you need data experts for collecting, cleaning, labeling. You need feature engineers for the selection, extraction, construction. You need some model developers for the selection of the right model, for the hyperparameter tuning, for the training, and so on. So you see, it's very hard without help. And there are already some tools, or a lot of tools for the automatizations. There are already a lot of big platforms which are helping or which are supporting the successful AI development. But these automatization steps also comes often with the expense of customizability and transparency. So that means that using these automatization tools, often you create black box AI where you don't know what happens, or if something works wrong, you don't know why this works wrong. And yeah, you use the possibility of customizability. So this is a problem we wanted to handle with our research work and then with our platform we created. And this problem is also underlined by looking at the current state. So there are already tools and platforms which addresses some of the problems. A well-known term is the AutoML. AutoML addresses the automation of ML development steps. So there are tools supporting hyperparameter tuning. There are tools supporting data labeling. There are tools supporting and tracking of parameters during the training. But the most tools are focusing only on individual parts of the pipeline. And the second point is the most tools also just pay attention on the model generation step rather than the data-centric status. So this is a problem. The second, and I think a lot of you maybe knows platforms like this, are the machine learning as a service platforms like Azure ML or Google AutoML. These platforms automate and scale the full pipeline. And with this platforms, it's very easy to develop and to train AI models, even for people who don't have the biggest background in AI, but you're required to use models predefined. You're required to use the infrastructure of them. So you have to upload your data. And yeah, you also reduce the model transparency because everything or the most steps are optimized. And yeah, this is the problem we mentioned. And when you go into the research or when you look at the research works, you can see that there are already works which addresses these problems. And I've written here 2 examples. There's one work or a work which containerized, so module, so looking at the whole pipeline, they also take the modular approach, containerizing the ML workflows in smaller steps and running them also into private clouds. But this work is very use case specific, so it's not possible to expand it on a generic example. There is a second work. In the second work, AutoML is integrated into a workflow management system, but also this work is very use case specific. But this is it's a base which shows that this topic is important, and it's a base where we can build on. So our current state-of-the-art research shows us that there's no existing works combining various requirements in a single platform, like the automatization steps and also the customizability and transferability, for example. So having these requirements or having these issues we have defined, we defined 3 research questions we wanted to answer implementing this platform. So the first research question is, how can benefits of existing machine learning as a service platforms, like mentioned Azure ML also on, such as automated resource management, can be combined with customizability and portability across various infrastructures. The second question is, how can users become involved into the machine learning pipeline to avoid black box AI? And the second and the third thing we also addresses is, how can code development, testing, and debugging, so all these steps we have to start when we want to develop a new model for a new specific use case. So how these steps can also be improved with the machine learning pipeline to take advantages such as the mentioned automated resource management. And so how these advantages can be already addressed during implementation. So before starting to answer this question, we have defined 6 for us very important platform requirements. So the first thing I already mentioned is the automated scheduling and resource management. The second things I also have explained before is the customizability and also the portability to different infrastructures. Then the third requirement is compatibility. So we don't want to focus on developing new AutoML features like new hyperparameter tuning algorithms, like new data labeling supporting. So we want to use already existing tools and platforms. So we need, or one requirement is the compatibility. The fourth point is the fault tolerance. So everybody of you who already developed or trained an AI model knows that training an AI model can take a lot of time. It can take days or even weeks or months. So we need a fault tolerance that handles temporary failures, for example, it's network issues or external service downtimes without crashing the whole pipelines. And this is done by supporting recovering and continuation of long-running pipelines after some failures. The next point is the human-in-the-loop approach. This is the approach where we want to increase the transparency of our model. So we don't want to do everything automated. We want also include the possibility to interact with the training process. And doing this, we want to avoid the black box AI. And the last thing is the improvement of the code development, testing, and debugging. So this is what I mentioned before, that already the developer starting by scratch can benefit from all these things mentioned before, like automated resource management and so on. And answering the 3 research questions before and to fulfill the 6 requirements, we have defined 3 approaches. So the first approach, you already heard this in the title, is machine learning, also defining the machine learning pipeline as a data-oriented scientific workflow. So what is a data-oriented scientific workflow? It's just a series of actions where each action is defined by an input and an output. So for example, if you have the AI training or AI development pipeline, you start with data download. So data download would be one action, and an input parameter could be the URL of the data, and an output would be a folder with the downloaded data. Then you have a next action. This could be the data pre-processing, where the input is the output from the action before, from the downloading step, and the output of this action would be the pre-processed data, and so on. And a workflow management system is now able, having this in and output of each action, to define the workflows. And having this workflows, this workflow management system is able to do the resource management, to do the scheduling. So the workflow management system can see or can recognize parts which can be done in parallel. Then the virtual machines will be start automatically, and also the virtual machines will be shut down after the processing steps. So our approach was to define or to encapsulate the individual steps of the machine learning pipeline into singular actions and define them as scientific workflows. So having this approach, it's possible to run them with a workflow management. And doing this, we already have fulfilling the requirements of scheduling, of resource management, and so on. And as a research management system, we are using Steep. You already introduced Steep very good, but I have also prepared one single slide. So what is Steep? Steep is a workflow management system, and Steep is able to orchestrate complex data processing pipelines. So everything you need is you have to define your actions, and actions can be a Docker image, and you have to define your output and your input of an action, and you write it down, for example, in a YAML file, and Steep do the rest. So Steep starts to makes the workflow, so it's the scheduling. Steep starts the resources, and your output will be the finalized workflow and data meet. So one important point of this is, I already told it before, that you just use the resources you need. So just the VMs are started which are needed for the processing step, and just so long as you need them. So after processing, they are shut down, and this is very, that saves a lot of cost. This was our first approach. The second approach to avoid the black box AI is the integration of human in the loop. So integrating the human into the AI pipeline, AI development pipeline, we want to avoid the black box AI, we want to increase the transparency. I have created here on the right-hand side where my laser pointer pointed now an example workflow. So we have here an action A and followed by an action B. This is the output of action B. And then here, this means the suspend action. So what happens here? The suspend action is something we have implemented that we can stop a running workflow, because by default, scientific workflows run without any user interactions, but we want to stop a workflow to be able to give some user input. And we have implemented the possibility of stopping this workflow, and this is called suspend action. This is shown here by this sign. And after a user input, these are the 2 points. This is the output of the suspend action and the input of the new one, of the new action. The workflow will be proceeded. And this is the second approach. And the third approach is the integration of Jupyter Notebook. So the question was how we can support also the implementing, the testing, and the debugging steps by a developer, by our platform. And our approach is doing this by integration of Jupyter Notebook. Jupyter Notebook is a primary tool for model development and testing. So we connected this into our platform, and doing this or having this connection, the Jupyter Notebook has the same or can benefit from the same things like automated resource management in background than already finalized actions. And how we have implemented this, I have prepared one slide. So we have here 3 main parts. We have our Kubernetes cluster where Steep is running. We have an open stack where some VMs can be started and cut it down. And we have a database. And on the top of the slide, the blue arrows are showing or are regarding the suspend action things I will explain in the next minutes. And the green part is related to the Jupyter Notebook integration. But let us first start with the suspend action part with the integration of the human in the loop. So what happens if a user defines a workflow? For example, we have here defined the workflow X, Y, suspend action, and Z. This workflow is put into Steep. And what happens now? Steep starts the actions X and Y. And for this, the best fitting VM or VM is started. So action X is processed. Then we have an output of X, that is an input of Y. Y is processed. And then we are at the part where the workflow stops, because the next action is the suspend action. And what now happens is that the intermediate results are written into a database, and we are waiting for the user input. And in this case, the user input is the number 42. So we have defined that we need, for example, a number as an input to proceed the calculations, and getting this number, which is written down automatically then in the database, Steep starts the next process chain, so the next part of the workflow, and this is Z. And this is then processed with the input of 42. And the same happens again. Steep is looking for the best fitting VM. Steep starts the best fitting VM. The things are processed on this VM, and then everything is shut down. Here we have a sequential workflow. In the case where we don't have a sequential workflow, where there are parallel branches, Steep just stops the part of the workflow which are relevant or which needs the user input as an input. So if there are parallel branches processed in parallel, Steep don't stop them. These are running through, but just these things are stopped where the user input is needed, as a side note. So this is the implementation or the approach, how we implemented the suspend action into Steep. The second thing, how we implemented the Jupyter notebooks or how we integrated Jupyter notebooks is shown here on the bottom of the slide. So what happens here? We have a Jupyter notebook, what the user is using for implementing or developing an AI model. And this Jupyter notebooks is running on our Kubernetes cluster on the kernel pod, and having just, I tell them, normal command without any special hardware resource requirements, without, for example, GPU, all these normal commands can be executed in our kernel pod. So if I just have simple calculations which can be executed in a CPU, these are done in the kernel pod. But in the moment where I need, for example, a GPU for the training some examples, I just write this command, this person steep, and everything which is written down are then processed in a GPU. And this is the part where the magic starts now. So what happens when I write down this person steep command? Steep translates this, what is written down in scientific workflow. So this scientific workflow is now here, this part. And then the same things happened with before. We have now automatically defined scientific workflow, and this automatically defined scientific workflow is executed like every normal workflow. So we have 3 actions. The best fitting VMs are found, the best fitting VMs are started, and after calculation, the best fitting VMs are shut down. And these things happened in the background. So as a user, you just have to define this magic command, and the magic happens in the background. And to illustrate you some benefits of our platform and looking at the 3 research questions we have defined, I've prepared 2 slides for demonstration. We can see here 2 images on this slide. First, we have a pseudo-labeling algorithm shown here and an active learning algorithm. Both algorithms are well known in the context of working with limited labeled data. So this is also a very big problem training AI models, but it's a separate content. But what I want to show here with this example is that we have a lot of modules or actions which are similar. So we have 2 totally different approaches, but we have the data download step, we have the data processing step, we have the hyperparameter tuning step, and just then we have one big difference. So in pseudo labeling, what happens? I start to train a model with the few data I have for my use case, and after the training, I have a predict steps where I predict new labels, and these labels are called pseudo labels. And these labels are then used for the next training steps together with these already existing labels. And this is an iterative loop. And after termination criteria, I finish the pseudo labeling part and I go over to the evaluation. Active learning is a bit different. Active learning also starts with training with the labels I have already available for my use case. But instead of creating pseudo labels by the already trained models, I include the human into the loop as a human annotator. And for this, I defined the suspend action because this is the part where a human has to interact. The human has to relabel, for example, parts of unlabeled data where big uncertainties are. So this is the criteria where a human can interact, but it's not so important for the demonstration. But what is important that at some part of the pipeline, the human has to interact and has to annotate some data. And this is the only big difference between the 2 algorithms. And now looking at the part starting or looking back at the beginning of our presentation, without our platform, First, it is not possible to use this human annotation step because using well-known machine learning as a service platform, you often don't have the possibility to interact. And the second part is, I think you're not able to define it so customizable you need. So this is one big advantage. You are able to implement every algorithm you want to or you need. The second part is that you don't have to implement everything new. So having just one, for example, Python script where you implement the pseudo-labeling training or the pseudo-labeling part, and one Python script where you have the active learning, translating this into the other takes time. And here in this case, we just have to substitute the predict action with the suspend action, with the human annotation, and it. We have a totally new algorithm doing one step, and we don't have to do everything else if we have both these actions already containerized as a Docker image. And the third thing I want to demonstrate is implementing all these steps can already be done also in our platform. And to demonstrate the benefit of it, I have prepared here this slide with these two images. On the left-hand side, we have an example without our platform, and on the right-hand side, we have an example with our platform. And it's very simplified, but imagine you have two developers and just one virtual machine available on your infrastructure where you can, with the GPU, where you can do some AI training. And without our platform, this could look like we have a developer. He or she starts in the morning the VM, the CPU and GPU, and starts developing. At the beginning, the GPU is not needed. And after a certain time, the GPU is needed, everything is processed. But in the afternoon, a second developer wants to use the GPU because at the same time, he also has developed some things and wants to test them in the GPU VM. But at this time, the GPU is not available. So he has to wait, or when the GPU is blocked the whole day, he cannot do anything. And having now our platform with the integrated Jupyter notebooks, this looks like a bit different. So we have a Jupyter notebooks. The first developer starts it on a pod in the Kubernetes cluster, and everything can be done in this pod till the pace or till the time arrives where he needs a GPU. And this time he writes the magic command. The GPU is started, Deep translates everything, or everything is translated into scientific workflows, and everything is calculated in the GPU. And after the calculation, the GPU is shut down. And when the second developer and the third and fourth and so on comes, and the GPU is not used, this can be started again by Steep. The resource can be used again, and nothing is blocked for a whole day. Or my experience showed that it's not often that it's just a whole day. Sometimes it's weeks, months, because you don't want to install drivers and libraries every day again. And you can share the GPUs VMs with your colleagues, but maybe your colleague has different drivers, and then there are some problems. This cannot occur in this case because everything is run without these requirements. And that's it. So what is the conclusion? We have defined the machine learning pipeline as a data-oriented scientific workflows, and defining this machine learning pipeline as this workflows, we are able to use scientific workflow management systems like Steep. And having these systems, Steep handles the scheduling, resource management automatically. Defining things as individual actions, we are possible to customize things very individual. So we are not able to use things predefined on machine learning as a service platforms, and integrating the human into the loop. We avoid black box AIs, and at the same time, we increase the transparency of our models, of our model development, and integrating the Jupyter Notebook into Stream. We allowed already developers to use or to leverage the benefits of our platform already during the development process. And the last thing is I want to conclude is that not only complex workflows and the use cases I have shown are good examples or good cases for using our platform, but also simple training and simple AI development can be done in our platform. Then the benefits of automated research management can also be seen in these cases. And what are the next steps? So the first thing is we want to support the execution of multiple branches after a suspend action. That means that having a suspend action, for example, in a training process where we stop the training process and define, for example, 3 hyperparameter configurations for the continuing training. We want to be able to execute this multiple branches independently. The second thing is that we want to have a detailed examination of the human in the loop approach. So we have created now the basis for it, but now we have conduct user studies on where and how the user should be able to intervene in the machine learning pipeline. We have to manage the trade-off between the automation and the interpretability. And this means that we want to connect this with an automated metric that stops automatically running workflows. For example, when training an AI model, when the accuracy is beyond the threshold, as an example. So we want to connect the automation with the user interaction. So this is one approach, how we want to manage the trade-off. And the last thing and the most important thing is after creating now the basis and the platform, we want to use this platform for the AI development of the modules we want to use or we have to use within the Focal project. And yes, that's it from my side. Thank you very much for your attention. And if there are I would be happy to answer them.
Great, thank you, Kevin, for that really interesting presentation. So yes, does anyone have any questions for Kevin? If you do have questions, just raise your hand and we'll get to you, or you can post your questions in the chat. Go ahead, Dean.
Yeah, I think I really like the presentation. Thanks. Really covers an interesting approach to handling how to automate and then balance that with human in the loop. When you're talking about black box AI, part of that obviously is having the flexibility of putting the human in the loop whenever you want. But could you maybe identify a few other criteria that I mean, it's sort of an intuitive term that you want to improve transparency, but in practical measures, how else, what differentiates sort of more of an open AI approach versus this black box? What are some other criteria of a system that gives you more transparency, more control, some sort of maybe from almost a detailed technical term in terms of, let's say, support for standards or, like you're saying, control of thresholds, things like that. So yeah, I'd like to kind of explore that a little bit.
Yeah, thank you very much for this question. That's a very interesting question, a very also important question. And as you already mentioned, our approach is to integrate the human into the loop to increase the transparency. But already the approach or the workflow-based approach, dividing the whole pipeline into single things, I think this already increases the transparency because you know what happens in the training process. The second point is that having this individual modules, you have individual in and outputs of these actions I have defined. So looking at these in and outputs, for example, you have the data preparation steps, you have an output of a data pre-processing, you have then an input, so you know what you're putting into the AI model. You can stop running AI training processes. So I think having this modular approach, you have a big possibility to see a lot of more things you cannot see when you just start in AI training or an AI development pipeline, and then you have an output. So I think this is also an important thing to understand what happens, and this also increased the transparency of the model a lot. So that's from my side as a developer and as a researcher. And I don't know if there are also other person in the round who wants to discuss this topic, but from my side, these things or our approach, also the workflow-based and modular approach increases the transparency in itself because you have a better understanding.
Yeah, I was just thinking about the AI process steps. Does Steep give you can you introduce thresholds, say, okay, keep iterating until you reach this threshold metric, and then pull the human in the loop? Maybe you already mentioned that, but I'm just wondering, is that part of Steep, or do you have to configure that within the AI?
No, that's very interesting because that is what we want to do now, or what we started to do now. So we want to integrate some thresholds, some automated metrics, where we want to manage the trade-off between the automation on one side and the human interaction on the other hand side. So this is very important and something we will do in the next weeks and months. So the focal project is now at the midterm, and now we have created the basis, and the second part of the project starts now, where we want to research and solve these things. Yes.
And from an IPT perspective, we're often talking about data lineage, but from an AI pipeline side of things, does Steep support some sort of process lineage, so that at any point, let's say there's a human in the loop, can they examine the process steps that have already been executed up to that point? And is that maintained somewhere at a system level? Process lineage.
What do you mean? Can you explain a little bit? Because I haven't understand your point, I think.
The idea was, is there somewhere that's logged or tracked from a high level, from systems level, all the process steps that have been executed up to that point? I mean, not obviously each action of the AI, but let's say at least this module has been repeated, 100 times, and it passed the threshold. This has been called. So at sort of the level of granularity of your process diagram, it would be interesting to, at any point in time, there's a pause, you could look at the process execution that's happened up to that point.
Yes, so there are two ways where these things are tracked and logged. So the first way is Steep by itself is doing logging. So you have the information about processed actions, where you can see into the outputs of each action. And the second way is we also integrated the possibility, for example, to use MLflow. So just looking at the ML part, it is possible to integrate, to use MLflow, or also Optuna, or other tools where you can track the AI training process. So Steep by itself is doing logging, and we also integrated external tools to log things. That was meant by the by the compatibility. So that was one requirement we wanted to fulfill, and we also integrated MLflow for logging and tracking.
Mm-hmm. And last quick question, then I'll let somebody else
problem.
jump in. I'm always coming from OGC perspective, we're always looking for where are there gaps in standards. So if there was, let's say, what would make your life easier in terms of having an open standard around process automation? If there was a process description language, or I mean, there probably are languages like that out there from outside of OGC. So if you do have standards like that you're already using, which ones are the most important? Or if you could, have someone invent a standard, what would be the most important standard, just to make it easier to orchestrate across these different process types?
Yeah, so for me as a developer, the biggest obstacle developing AI models is always the data. It's the training data, and in detail, it's the labeled data. And one problem is that there's no standard, or no standard for labeled data. So you have always the problem that you sometimes even don't have labeled data. In the case you have labeled data, there's no standard. You don't know how this data is labeled. What is the accuracy of the labels, who labels this data, the year. So you don't have any information. So you have to go into your labels, you have to look at them, you have to evaluate them by your own. And their data sets or labels were maybe used by a lot of people, and everybody is doing this because there are no standards. So for me, when I could wish something, I would wish a data standard. I wish labels and a data standard for the labels. So this is for me the biggest obstacle always starting development in an AI model. So yeah.
Is that something you could use JSON schema for?
I haven't used JSON schema before, so I'm honest. I don't know, but I will look on it.
Like, for example, one thing I was doing on a fairly simple
in JSON scheme. Oh, sorry, I understood you. Yes, it would be a possibility to define a JSON scheme for it, and to have some information, because now you don't have, most time you don't have any information since there's no standard. So yes, a JSON scheme
you're
would help.
missing the context. You don't understand the data structure, the context, or the label.
Yeah, sure.
Yeah. I mean, the nice thing about JSON schema is it's already used a lot by OpenAPI and
sure.
others. Yeah. Okay.
So our workflow is also defined, so you can define it by YAML or a JSON scheme. So that would be a nice way to do this, because it's also included in Steep.
Cool. All right. Well, thanks a lot for answering those questions. Very interesting approach.
Great, thanks, Dean. Any other questions for Kevin? Maybe I'll ask one question. So I was curious, the pausing, like the pausing methodology you talked about, that would allow the system to automatically stop to allow human in the loop interaction. I'm wondering if that like something like that could also be used for like cost management, for like if the system can monitor, like if you're testing something, I would imagine that you might not have a sense of how much it's going to cost from a processing perspective. So if the system could monitor that and automatically stop whatever it's doing if it incurs a certain amount of cost, so that you could evaluate what's going on, rather than running processing continuously and incurring a bunch of different computing costs. I was wondering if something like that would be possible as well.
Yes, sure. So that would also be one metric we could define. So I already mentioned that we have to identify a sensible matrix, and one metric could also be the cost. So after reaching the cost, the workflow is stopped, and then the human can decide what happened later. So sure, yeah.
Okay, cool. Thank you. Any last call, I guess, for questions for Kevin? Anyone else? Any other thoughts? Yes, Piotr.
Yeah, so I'm putting some links in the chat about the labeling. I guess there was some attempts to do the training ML within the OGC, which is a standard now. but I haven't seen many implementations. But the question I have is more, let's say, technical. So from your experience, like you were developing this scripts or code for these processes, how specific is that to this platform? You may have taken some of the pieces from somewhere else, so this could be one thing. And then you have this magic which which happens in the meantime. So I guess kind of decoupling the whole workflow into kind of step that then are matched to what you call the most relevant VMs. So I wonder how much it depends. This implementation depends on your platform, because in the beginning you mentioned about the portability also. So yeah, that is probably the.
So yeah, you have, I think, two parts are important for the answer. So the first part is you can develop Steep on every infrastructure. So you're not required to use AWS, for example, or I don't know what. So you can carry it out to any and also private infrastructures. And the implementation of the actions and modules which are processed into a workflow and executed by Steep, they're totally independent from Steep. So you can define your Python script or some code. It don't have to be Python, everything. You can then Dockerize it, and these Docker images are then used by Steep for the calculation. So you're totally independent from the platform. And what I mentioned with the VMs, so defining these actions. So an action is, for example, a Python script in a Docker image, which will be started and stopped. You also define hardware requirements for action. So you can say that you need a GPU, you need, for example, 16 gigabytes RAM, and then a Steep looking for VMs which can be started in the pool of possible or existing VMs which are fulfilling these requirements the best. So you're from the implementation side, you're totally independent from the system. You can use everything. You can Dockerize, can be run by a Steep.
Okay. Yeah, thank you.
Yeah, I was just gonna confirm. So the link I put in the chat, that's the right landing page for steep.app. Is that correct?
I just took the freedom to post the correct link, though that's something else.
Oh, really? Good. I'm glad I asked. All right. So it's is it an open source project or?
Yes, it is.
Okay.
So, and maybe one important or interesting point, Steep is not bound just to AI development. So we had our Focal project, and we decided to use the benefits of Steep to support the AI development. But before having the Focal project, since a lot of years, we are using Steep as a workflow management system in a project in the German Telekom, Deutsche Telekom. So for the fiber rollout, Steep is used for a lot of things for resource management. And in this, we have also workflows where an orthophoto classification is done for the planning, where other calculations are done. So you have a lot of independent services and a lot of independent models, and everything which is possible to containerize and to Dockerize can be run and managed by Steep. So it's not just bound to AI. It was vice versa. We saw the benefits from our project and wanted to use them for AI development.
Right. And does Steep support MCP, or is that sort of a lower level that would happen within a process that you publish to Steep? Model context protocol. Like, I'm just wondering if you
Yeah,
So maybe that's more in the
I'm
weeds of how you attach a new process, like you're orchestrating. Is there an option to plug in processes using MCP?
Yeah, hey, maybe I can just step in. So I'm Hendrik, also in the team from Kevin. No, not directly in Steep. So the architecture would be that you have an MCP server somewhere else, and when it gets request, then it encapsulates it into a workflow and communicates with Steep. Of course, you could also write a plugin to Steep, but I think in the sense of a more decoupled system, it would make more sense to have isolated components for it.
Okay, so Steve could make an external call via MCP to an external process and then wait for an answer. Yeah,
exactly. Yeah,
because that might be because it sounds so. Then Steep actually it's sort of an integrated architecture where it's running on a platform. It doesn't have to be AWS. It could be any platform, but it doesn't span multiple platforms. You kind of have to configure Steep on one platform, and then if you want to call anything externally, you'd have to do that via something like MCP.
In the sense of VMs, you can also use different platforms. But if you want to call external services, so it does not need to be MCP, it can also be some other external
Open
service.
API, whatever.
Yeah, for example, then of course, yeah, then you would need to make external calls.
Right. Okay. I think I understand now. Thanks.
And Piotr?
Yeah. Have you looked into the other representation of the workflows? I'm particularly thinking about the CWL, which is used in the some of the OGC good practices about application packaging, and I guess there's a couple of things that should be probably translated in some way. There are some also examples how to translate it to specific infrastructures, and from this perspective, like taking CWL from the platforms that I've seen the discussion about, like Apex or Earthcode. Do you think it could work, or how much work is needed to adopt?
Yeah, that's a nice point, because of course we had a look at Common Workflow Language, and the big problem is that, to my best understanding, it does not support multiple branches without a priori runtime knowledge. That means if you start a workflow and during workflow execution you have a loop and the exact number of iteration is not known before the loop finished, then you are not able to model it in Common Workflow Language. And for our use case, it's very important because, for example, at the end of the loop, you decide in this append action, do I need another iteration of this loop? If yes, then schedule it, or if not, finish the workflow. And we were not able to model this in Common Workflow Language, so we again introduced our own definition for this.
Yeah, that could be true what you said. I mean, there are probably some workarounds that I've seen when people were using the scattering, distribute the work over the area to multiple threads, and they were simply introducing some additional steps, I guess, in the workflow to do this work. But yeah, that could be true. And also suspend is probably not supported.
The typical workaround is to start sub workflows, so you finish your parent workflow, if you want to name it like this, and start a dedicated child workflow. But of course, it blows up all your logging and so on. So it had benefits and drawbacks.
Yep.
One quick question.
Galaxy, I think. Sorry, go on, Dean.
Oh, I was just a quick question about calling the appropriate VMs. So there's the appropriate, and then there's the appropriate number. So does Steep autoscale based on process requirements? Let's say that data set's bit large, and you have some kind of configuration about how much process you're allowing, and so if you increase the urgency, maybe it could auto scale.
Yeah, you can configure everything. So we have a total limit of VMs that are allowed to start. You have a limit how much are allowed to start in parallel. So you can also say how fast do I want to react if I get new tasks. So it depends on your configuration.
Okay, great, thanks.
Okay. We probably have time for one more question if anybody else has one. Okay, doesn't seem like it. So, okay, well, thank you again, Kevin, for giving your presentation today. It was really interesting. It was great to see some good discussion about it. So thank you so much. I don't think we have any more scheduled webinars for the Focal project yet. I believe we'll have to talk with Muthu at OGC about potentially future webinars that we'll do. But those will certainly be announced through OGC at as they come up. And I believe just to highlight, so the next potential meeting of this working group, of the Climate Resilience Domain Working Group at OGC, would likely be at the OGC's the next OGC Connect meeting, which will be in Cape Town in South Africa during the week of October 19th. So aside from the week, nothing else has been scheduled about that, but that's certainly an opportunity to connect with this community in person during the next OGC meeting. Yes, and Muthu has said that the presentation will be made available on the Focal YouTube channel, so will be available to everybody. So yeah, with that, thank you everyone for joining today, and enjoy the rest of your day. Thanks.
Thank you.
Thank you.
Thanks.
Yeah, thanks, Kevin.
Bye.
And
Bye.